You're welcome back from break. Let's continue from where we stopped. Let's consider this example 4. But this example 4, in the past question where it is brought, it is to be used to answer 2 questions, question 41 and 42. So that means we are using the same table to answer question 41 and 42. We answer them one after the other. Now, look at this table very well. You can see that the intervals we have there is not of whole number limits. They are of decimal limits. The upper limits are decimal. The lower limits are decimal number. So we want to see how to address this kind of question. Let me start from the coefficient of boundary. You know, I taught you that when you want to deal with boundary coefficients of intervals with whole numbers as upper limit, whole numbers as lower limit. This is what I mean. You have 3 to 5 as the limit. The lower limit here is whole number 3. Upper limit here is whole number 5. To deal with that, I told you that I will be subtracting 0.5. That 0.5 as the boundary coefficient is not going to be the same in this. But how do we determine boundary coefficient? That is what I quickly want to explain to you, so that in any exam you can determine your boundary coefficient and know what to add and what to subtract. Now, in this case, the boundary coefficient will be determined by finding the mean of 1.5 and 2.4. When you find the mean, you now subtract from it the upper limit of this first class. So that is if you are using the first and second classes to determine the boundary coefficient. Let me explain once again. Find the mean of 1.5 and 2.4, that is the lower class limits of the first class and the upper class limit of the next class, whichever class you are using as your own first. So when you find the mean, you now subtract the upper class limit of the previous class you use, which is this 1.9, from it. It will give you your boundary coefficient. That is 1.5 plus 2.4. That gives 3.9. Divided by 2, you know that is the mean. You get 1.95 if you do it correctly. So you now subtract 1.9, this 1.9 from that 1.95. You will get 0.05, and that is going to be your boundary coefficient. And that is what you are going to be getting even if you use any other class intervals here. Just like if you come here to use this class limits, to use this, that is this class and this class. So you find the mean of 3.0 and 3.9. That is 3.0 plus 3.9 will give you 6.9. Divide it by 2 to actually get the mean. If you divide it by 2, you will get 3.45. So if you get 3.45, you now subtract this one, the 3.4 here. Subtract it from your mean. It will give you 0.05. It is a constant thing. Go down, do the same thing, you get the same answer. Come up, do the same thing, you get the same answer. So, in a nutshell, 0.05 is the boundary coefficient for this table because of the decimal. It doesn't mean it is going to be 0.05 for every decimal. I don't say that. But use the method I teach you now, you will get the current boundary coefficient. Now, having gotten the boundary coefficient to be 0.05, let's go ahead to the business. Find the mode of the distribution. You are using this table to find the mode of the distribution. So mode, as I've told you, mode is L1 plus dB over dB plus dA times C. I have told you the L1 means lower class boundary of the modal class, since it is of mode. If it is median we are dealing with, the L1 will be lower class boundary of the median class. First and foremost, what's our modal class? To determine your modal class, determine your modal frequency. The modal frequency will be the highest frequency so far in the table, which is 21 here. Therefore, the class that corresponds to that is this class that I ring, and that is our modal class. If this is your modal class, then determine the lower class boundary of this class. Is you subtract your boundary coefficient from the lower limit 2.0. So subtract 0.05 from 2.0. What is that going to be? That is going to be 1.95. Do you understand? So plus, what is dB? That code means D for difference. The difference between the modal frequency and the frequency before it. The B is before. Modal frequency, the difference between the modal frequency 21, frequency of the modal class. So the difference between that 21 and 2 is dB, and that is 19 over 19 plus dA is the difference between the modal frequency and the frequency after it. Frequency after it is 4. So the difference between 21 and 4, that is 17. 17. While our C is the class size. I've told you class size is gotten by just subtracting. Come to the limit column, subtract a particular limit of a class from the limit of the next class. 1.5 subtracted from 2.0, so that is 0.5. And if you come to the upper limit, do the same thing. 1.9 subtracted from 2.4, you get 0.5. 0.5 is our class size. So this is what you have to compute, and it will be 1.95 plus this 19 times 0.5. That will be 9.5. Half of 19 will be the result. 19 times 0.5. Now, 19 plus 17, that is 36. So, which is equal to 1.95 plus. In the exam, you actually have your small calculator on the system, because something like this you will need calculator. You have to be very fast at using it. Press your calculator for this. 9.5 divided by 36, and that will give you 0.26. 1.95 plus 0.26 will be 2.21. Now, looking into the option, you can see that the options are left in one decimal place. So, this approximately will also be 2.2, which corresponds to option B is the correct option. Let's consider the next question under that example 4. We are using it to answer two questions, just as it is in the past question where we draw it. Find the median of the distribution. To find the median using this table as well, how do we go about it? Median is L1 plus N over 2 minus CFB over FM, then C. I've explained to you before now, L1 is the lower class boundary of the median class. How do you discover your median class? In this case, what is the summation of the frequency. The summation of the frequency here is 60. So summation of the frequency here is 60. Half of the 60 is 30. It is that 30 that we use to locate the median class. 2 plus 21, that's 23, plus 4, that's 27, plus 15. Definitely it is at this point, it will reach that 30, it will even be more than it, but the fact that it reached it here, that makes this ring to be our median class. So this is our median class, the time ring. If this is our median class, what is the lower class boundary of this class? In the previous question on this same table for mode, I have explained to you that we subtract 0.05 from 3.0, that one gives you 2.95. So plus n here, 10 summation f, which is 60. 60 divided by 2, that is 30. Minus CFB is cumulative frequency before the median class. You can see that this is the median class and the median frequency is 15. So the cumulative frequency before getting here is this. So what the addition? 2 plus 21, that's 23, plus 4, that's 27. So that is 27. I hope you are following. C is the class size. I have told you, just subtract any one, 1.9 from 2.4, it gives you 0.5. 0.5 is the class size in that case, divided by FM. FM is the frequency of the median class. This is the median class. What is its frequency? 15. 15 is the frequency of the median class. So we have 2.95 plus, now 30 minus 27, that's 3. That's 3. 3 times 0.5. Anytime you use 0.5 to multiply something, you get the half of that thing. So 3 times half means half of 3, which is 1.5. Do you understand? 1.5 divided by 15. Looking at this critically, you see it is going to be 2.95 plus, if you have 15 divided by 15, what's going to be your answer? Normally, that's 1. But this is 1.5 divided by 15, which is going to be 0.1. Do you understand? So, add these together. This will be 2.95, 0.10, add this, you have 5, add this is 0.3. So it's going to be 3.05, yes. And that is our answer. But looking into the options, you can see that the options are left in 1 decimal place. So you convert this to 1 decimal place as well. Approximately, this will be 3.1 to 1 decimal place. So our correct option is option A. Let's consider example 5, which is going to be where we are going to draw curtain under measure of central tendency of grouped data. So find the mean of the above distribution. This is the table. So what do? We write interval quickly. Then we have mid value or midpoint, which is our x value in this case. Then frequency, we have fx because we need mean. So the class interval 3 to 5, 6 to 8, 9 to 11. So to get the midpoint value, which represents X value in group data, whenever you need to find mean, you need X value, because mean cannot be changed from being summation Fx over summation F. It will continue to be like that. So we need X. And in the interval, there is no X, except you create midpoint value, which represent the X value on a grouped data. So to obtain the X value, which is the midpoint value, you find the average of every interval. What do we mean by average? Mean. You find the mean of every interval. If you are to find the mean of this, what do? You say 2 plus 3 divided by 2. That's mean. If you are to find the mean of 1, 2, 3, you say 1 plus 2 plus 3 divided by 3. So that is what we mean by finding mean. So what's the mean of 3 and 5? That is 3 plus 5, that's 8, divided by 2, that is 4. That is the X value for that. Also here, 6 plus 8, that is 14, divided by 2, 7. That is X value for that. The same thing, 9 plus 11, that is 20, divided by 2, that's 10. That represents the X value for that. So now that you have X value, and our frequency is already given, 2, 2, 2. Don't mind them. Deliberately put it to be the same figure, but that doesn't mean it will continue to be like that. It could be any value. Now, what is Fx? Fx is frequency times X. 2 times 4, that is 8. 2 times 7, that is 14. 2 times 10, that's 20. So adding these together, 8 plus 14, that's 22. 22 plus 20, that is 42. Summation F is 6. Therefore, mean equals summation Fx over summation F. That is constant as the formula for finding mean, whether group data or ungroup data. So far, it is in table, in tabulated data. So that is it. Where our Fx summation is 42, then summation F is 6. 42 divided by 6, that is 7. And that tallies with option D. So that is our final answer.